Okay, now we go to example 11. A vacuum parallel plate capacitor has plate of area 150 cm square and separation 2 mm. The capacitor is charged to a potential difference V0 equal to 2000 volt. The battery is disconnected and a dielectric sheet of the same area A is placed between the plates. In the presence of the dielectric, the potential difference across the plates is reduced to 500 volt. Determine A, the initial capacitance and initial charge of the capacitor, dia minta C0 and Q0. B, the capacitance after the dielectric is inserted, dia minta nilai C. And C, the permittivity of dielectric materials, dia minta ER. And D, dia minta E. And D, the change in electric field after dielectric is inserted. So, dia minta delta E. Okay, now we go to the first one. We take out all the info. So, info yang ada, kita tahu areanya ialah 100 exponent negative 4 meter square. And we have the distance 2 exponent negative 3 meter. We have the initial voltage 2000 volt. And we have V is equals to 500 volt. Okay, so we know the voltage is changing, means that the battery is disconnected. So kalau battery is disconnected, maksudnya Q kita akan constant. So battery is disconnected, so Q constant, V changing. So as we look here, V dia pun berubah daripada 2000 pergi ke 500. Okay, so A dia minta the initial capacitance dan initial charge. So C0 equals to epsilon naught A over D. Okay, kenapa? Sebab pada awalnya dia berada di air sebelum dia diletakkan dielectric materials. Okay, mula-mula dia air je, lepas tu baru letak dielectric sheets. Okay, so C0 is equals to epsilon naught is constant 8.85 exponent negative 12. The area is given 150 exponent negative 4. Sebab dia centimeter square, so dia negative 4 square bukan negative 2 square. And the distance is also given 2 exponent negative 3. So kalau kita kira, kita akan dapat C0 is equals to 6.64 exponent negative 11 farad. Okay, and the question also asks for the initial charge Q0. So Q0 is equals to C0 V0. So C0 is 6.64 exponent negative 11 and V0 is given here is 2000. Okay, so kita akan dapat nilainya ialah 1.33 exponent negative 7 coulomb. So itu A. Okay, now we go to B. The capacitance after dielectric is inserted. Dia minta nilai C yang baru. So we know that C is equals to epsilon A over D. But we don't have epsilon, so we cannot use this formula, but we can use formula ER is equals to C over C0. Kita nak cari C, so C is equals to epsilon R darab C0. Do we have epsilon R? Yes, we do have epsilon R, which is given, is it given? No, it's not given, but we can find epsilon R. It's not given. Okay, but we can find epsilon R by using formula ER is equals to V0 over V. Okay, so 2000 divided by 500, kita akan dapat 4. So kita substitutekan dalam ni, equals to epsilon R is 4 and C0 kita dah kira tadi ialah 6.64 epsilon negatif 11. Okay, so kita darabkan sahaja, kita akan dapat jawapan kita ialah 2.65 exponent negatif 10 farad. Okay, alright. So, settle for B and see the permittivity of the electric materials. So, permittivity dia minta nilai E. So, kita tahu relationship ni ialah ER is equals to E over epsilon naught. Dia minta nilai E. So E is equals to ER E naught. So ER kita tahu dia ialah 4 dan E naught 8.85 darab 10 negatif 12. Okay. So kita darabkan sahaja kita akan dapat 3.54 eksponen negatif 11. Unit ni ialah C square N negative 1 M negative 2. Okay. So this is for C, and the last one for D, and for D dia minta delta E. So we know that delta V is equals to ED sebab dia ialah parallel plate. So kalau parallel plate, E is equals to delta V over D. So delta V ialah change 2000 minus 500 and divided by 2 eksponen negatif 3, kita akan dapat jawapan kita ialah 7.5 eksponen 3 volt per meter. Okay, so this is for D. Right, so that's for the example number 11. Thank you.